Welcome to my talk on giving a good Jupyter talk. So this is part of our PyHEP Topical Meetings, our module of the month. And this month, the module is Jupyter. But this is a little bit different from the other module of the month talks, which are really about the technology of a particular Python module. This one is assuming that you already know, well, at least know about Jupyter and maybe have used it a few times, or if you're not familiar with it, that you can find out on your own. The focus of this talk is actually on the social aspects of giving a talk. I will show some of the technology, like where to find settings for making the font sizes bigger and such, but really more of this is focused to giving better talks, which is something that technology doesn't just do for us. It's as a meta talk, being a talk about talks, we can also use it as an example of good and bad behaviors. You can tell me after, actually, as we go along, oh, this is working or that isn't working. But I'll be talking about the talk while I'm giving the talk, because it serves that end. So to begin with, you probably see that I have Slido up here. If you haven't joined Slido, please do. It's not a service that you have to join or anything like that. You just go to slido.com and enter this number, and then you're in this meeting. You don't even have to put in your name. You can ask anonymous questions. So what this will look like is, you ask a meta question like that. I'm not going to add my name. And then it shows up like this. And great. And after we get a few of these, we'll just go how to clear the board. And that's how we'll ask questions. Please don't ask questions in the Zoom chat, because that goes by and people join late and all sorts of things. Okay, so here's the Indico page where all of the links are. Actually, you can go to the GitHub repo where all of the links are there again. You've already found the Zoom link because you're here. If you want to more fully participate in this and try out some of the things that I'm doing, while I'm doing it, clone this repo, install Jupyter Lab especially, but maybe Rise and maybe Voila Reveal on your computer. These are instructions for how to do that. I've already mentioned joining Slido. This is a link that does the same thing as that. You're already in Zoom. And launch your own Jupyter Lab. So one of the things that we'll be showing here is how to set up Binder, but this talk in itself is not binderized. So you'll have to run Jupyter Lab on your own computer. All right, so with that out of the way, you may still be installing things while I'm giving the intro talk. And another part of this meta stuff, I think it's good to, even if you're going to be doing a talk in Jupyter, to start with some conventional slides, some non-interactive conventional slides, because it's easier to write, good context setting slides in PDF form using like PowerPoint or Google Slides or Keynote or whatever, than it is to try to do it in Jupyter itself. So anyway, so let's go with context. So first of all, I've always felt that we have the three modes, fundamental modes of computation. If there's a fourth, then I don't know about it yet. And these are kind of rough categories, but you can do computations in a batch mode. This is the oldest mode of using computers to compute things. You write files or punch cards, you load them up, let it go. Maybe it doesn't run for an hour, because you need to get onto a time sharing service or whatever. But it's, the whole procedure is described ahead of time, and you just want it to run and give you the results at the end. At the opposite end of this, there's a terminal. you have a question that you want to ask the computer. So you bring up a Python prompt and you say, well, what would happen if I say for I in range 10, print I? And you press enter and you get the results, and you can go interactively back and forth with the terminal. And that has its uses. The batch mode is very permanent because you've made files that if you did the wrong thing, you can change them and do it again. The terminal is very ephemeral because what you typed there, if you want to see it again, you've got to type it again. As soon as you close this process, all of that is gone. Notebooks are a third mode of computation because they're kind of in the middle of that. They have this interactive back and forth like a terminal, but it's permanent. It makes a notebook file that you can save and you can load it again. And if you had good discipline, you can evaluate the cells from beginning to end and get the same results. If you didn't have good discipline, you're evaluating cells out of order, and it doesn't work the same way. So we've been talking about this as kind of a new idea, especially a few years ago when Jupyter was first becoming big. But it's, I think, worth knowing that actually this is such a fundamental idea that it is in fact not new. The earliest example I could find is from 1982. Xerox's Tioga editor for the Cedar language. And just as a side comment, Xerox PARC invented everything GUI related, including like the mouse and Windows and hypertext and all that. So it's kind of not surprising that they also invented notebook interfaces. But here it is in 1982. You write some code and it evaluates in cells and it produces graphical output, and you evaluate the code again and you have interactive prompts. It's, it's the whole thing. How many years ago? 90, it's like 40 years ago, almost. But that wasn't on PCs. The first on PCs was MathCAD in 86, and that sure looks like a PC from 1986. 1987 is when Mathematica came out, and it came out for early Macs. So that looks very nostalgic to me, by the way. I had another screenshot from MathCAD, but this one's on Windows. In 2000, there was a notebook interface that had a maximum number of users that was 1. I can say that with pretty clear certainty. I really liked the Mathematica notebook style. But to do high-energy physics, I needed to use PA. And so in Emacs, I made this notebook interface. You write in a thing and you get the output inline and you keep writing the thing. And I felt even then that notebooks were really the way to do analysis. And I'm just glad that they're mainstream now. They got mainstream largely because of IPython. So IPython is also pretty old. Some almost 20 years ago, IPython came out. You can see that this is a screenshot of Python 2.2. It was compiled in 2002. Cell-based Python in the terminal, and it looks a lot like that today. And by 2005, we had the whole thing, Sage, cell-based Python in a web browser. But it didn't become popular. It was around, and it was supposed to be like an open source version of Mathematica, but it didn't really get a lot of traction. The idea didn't get a lot of traction until 2012, when IPython started having different backends. One of them was Qt, but another one of them was your web browser. So IPython Notebook is cell-based Python in the web browser, but is popular this time. And that's when it really started to take off, because IPython changed its name to Jupyter because it was not limited to Python. And they wanted to make that, they wanted to emphasize that fact by, in fact, the name Jupyter comes from Julia Python R, what the author felt were the 3 most important languages for scientific computing. 2016, Binder is putting Jupyter notebooks in the cloud, making really helping tutorials and things. We'll get to that with the last part of this talk. 2018 Google Colab is Jupyter-ish notebooks in the cloud. It's not, it's like, I think it's like a fork of Jupyter. Oh, there's a question here. Have you found a good means of distributing Jupyter talks to people that don't have Python installed on the machine? Well, actually, it's getting to the point where not having Python installed on the machine is kind of like not having a web browser. It's starting to become a base expectation. I think that it might be possible to do a Conda installation without Python, but I'm not entirely sure. Whether installing Jupyter using Conda also, as a side product installs Python, I'm not sure. So I really can't answer that question. Also the same year, Jupyter got rewritten as Jupyter Lab to be a fully featured editor in the environment. So now it's starting to look like Tioga, and actually, so kind of toggle back and forth between these things. It's kind of funny. It's 40 years between these two things here. Okay. The reason is but main thing though now is that Jupyter and notebooks in general are mainstream. And actually, these are Google Trends searches, which is what I use to determine how popular something is by whether people are Google searching it. You see, IPython was rising, and actually IPython is falling now that Jupyter is taking over. And I thought that was kind of interesting. Mathematica has been on a slow decline for a long time. This is Sage Math. You see, it just never really took off. And Google Colab is actually higher than this if you don't include the word Google in it. It meets Colab by itself is about the same as Jupyter, but that search term has a lot of background. So now notebooks, as I was saying, they are a fundamental mode of computation. So there's a lot of different reasons why someone might be using notebooks. Quick prototyping, iterative investigation, such as data analysis, literate programming, so interweaving a program and text, publishing a widget that other people can run, and giving a talk or teaching a class that others can join in real time. And it's really just the last one of those that I'll be talking about. So now, when you're trying to do this, when you've done it a few times, you get some feedback. I feel like the common problems are these, and this is what the rest of this talk is going to be about, addressing these problems. One is the font's too small, because a tool designed for you to use on your own computer has is meant to try to get more text onto the screen so that you can be more productive with it. It's not meant to be projected so people in the back row can see it on a projector screen. So the second is like it, you're scrolling too fast. Because the notebooks are scrolled, people don't realize when they're presenting that their hand-eye coordination, whereas this looks fine if it's your own hand and your own eye watching this go up and down. It's really a problem if you're watching it on a screen and it's not your own hand. You don't have that hand-eye coordination, feedback loop. Too much code in the cells is a thing that we'll address. This is a problem with people are thinking that you're writing programs, but for someone in an audience to see a whole program on a screen, they're just not going to be able to take it all in. We have to write code differently if we're presenting it. And it doesn't work for me. This is if someone tries to install it on their machine and it doesn't work the same way as you're presenting it. The cloud tools like Binder, of course, Swan, I'll be talking about those, are ways of dealing with that. Okay, so I'll clear the first question about Python, which unfortunately I wasn't able to answer. Any other questions before I move to the actual notebooks? which we can do now. During this intro talk part, you've had some extra chance to install the Jupyter Lab at least. And also it's given people time to join if they're joining late. I prefer that to waiting 5 minutes at the beginning and doing nothing for 5 minutes. Okay, so if there's no questions, each of these notebooks in the repo that you have maybe downloaded and are working with, each of them addresses those 4 questions. It's too small, you're scrolling too fast, too much code in cells, and it doesn't work for me. Let's start with the it's too small problem. So yeah, I mean, in fact, you're looking at it. Jupyter's default text size is really small. You're seeing this in a Zoom window, which maybe you've made it full screen, and maybe that helps. Or you're seeing this after the fact in YouTube, where maybe even the resolution of YouTube is you know, pixelating those the text there so you can't see it. So, you know, and that it makes sense for the default text size to be this small because maybe you're doing literate programming. Maybe you're not using this for a talk. And then, you know, having text sizes small, you get to write full paragraph explanations of your code samples. But the smallness of the code looks really, really weird especially when your line is long like this. You know, have like a full paragraph of text, but it's this one skinny line. You know, like in newspapers, how they put text in columns, or even in blogs, how they make giant margins so that the text is not very wide. It's because when people are scanning, it's difficult to find the next line. And that's especially true if they're just watching a talk in real time and they've only got a minute to look at the slide before we go on to the next slide. So at least we need to make the text size bigger. So what can we do about that? So if I was sharing just one window in Zoom, which I'm not, I'm sharing this whole desktop so you can get, you know, the other windows here. You can make that window effectively bigger by, you know, making the window itself smaller. You know, if you do this and Zoom automatically resizes for you, then it will fill the audience's full screen view of it, you know, with the size of this window. So for that reason, in most talks, if I wasn't doing this Slido thing, I would share a window instead of sharing a desktop. So it would have that that possibility. Another thing to do is since this is a web browser, we can just resize the page zoom. I think for me, this is Control wheel, you know, mouse wheel. It's also up here somewhere. And to be honest, this is what I do most of the time. The disadvantage is it makes the side stuff bigger, so it's eating up screen space that could be used for something else. There's some things you can do about this, like simple interface that hides the tab. There's also a status bar down here that we can get rid of. You know, when you're looking at this, you also find this presentation mode, which I've not found this to be very useful. All it does is makes the text a little bit bigger. Okay, but oops, sorry about that. Scrolling problem again. Makes the text a little bit bigger, but it's generally not bigger enough. So yeah. So being in a web browser, you can just scale it, but that increases the size of the screen gunk around it. We could, right, so that's the problem. The window decorations are big. You can get rid of some of the window decorations, but not all. And I showed how you can find that from the view menu. Now, the markdown lets you set the font sizes. So if in this markdown, which I'll show you the cell here, I can use HTML like the font tag or new style HTML, where I just make a paragraph or even a div, I suppose, with the style font size being big. Oddly enough, these sizes are not the same. Font size 25 is the same as style font size 50 px. Someone with more CSS details can maybe say why, but I don't know. You can make so you can make the markdown as big as you need to, but then you have to be writing HTML all the time. You don't get to write markdown. And then also the code is still too small. I think when you share a window only in Zoom and make it smaller, you also lose resolution. Oh yeah, if you make it too small, it can be blurry for others. That's true. You lose resolution. That is true. It's a point I never thought about. Yeah, you're right. Okay, that is a good point. So I guess generally, changing the zoom in the browser is a better idea. Yeah, so the code is still too small though. If we have code like this, you're still seeing it kind of small. How do you get the white space above? What can you do about that? Well, BR, HTML tags. I also could have done like a style margin top, equals 100 px or something like that. Now we can also get really tricky. You can manually override the content and code font size, and we can deal with both the content and code size without affecting the size of the window decorations. That's under settings, under the theme. You can increase the code font size. Actually, I should show that while I'm doing it. Settings, theme, code font size. Keep watching it. Now it's a little bit bigger. Settings, theme, content font size. Now it's a little bit bigger. You couldn't just keep going to that menu, and especially since it doesn't have a keyboard shortcut. It takes forever. So you can go into the settings editor, which I think is a control comma. So as soon as you start doing that with the menu, it puts the settings right here, and now we can just like change it, And as soon as you save that, it becomes big everywhere throughout Jupyter. So that's a thing that you can do, and of course you're doing this just to your own view of Jupyter. This is not happening to anybody who's following along, like I hope you are, with your own Jupyter labs. It's independent. So this is a screenshot showing how you do that. Now you've done this, and it's permanently set bigger. So if you are done with that, and you're no longer presenting, you can just remove this, and it goes back to normal. Now, if you're thinking, I have to scroll. Where am I? Here I am. Sorry about the scrolling. If you're thinking that you could just comment this out so that you can uncomment it later at the beginning of your talk, be forewarned, any menu modifications will make Jupyter overwrite that settings. So any comments that you put there will get lost. So if you want to have like a bag of tricks file kept somewhere else, so you can just paste it in, then that will work. But if you think you're going to save it in there as a comment, as commented out CSS, I'm sorry, not CSS. This is like some JSON. If you want to leave it commented out, it won't stay commented out. In fact, that's not JSON. I don't know what language that is. Finally, one really tricky thing that you can do is this. You can evaluate, you can produce any HTML in your notebook by evaluating a cell. You can make that cell be a CSS style that resizes the editor cells, the output cells, and the markdown output. And you can do them all independently. You have to know what the CSS class names are. It happens to be JP editor, and it's the div inside that, and JP output area, and it's the pre inside that. But if you know that, then you can make everything bigger by evaluating a cell. And this, everything stays big in all of your windows, as long as this HTML exists. This invisible HTML here, this is what is making everything big. So if we reevaluate the cell without that, like we comment this out and reevaluate it, then it goes back because that HTML is gone. And actually it takes a little bit of clicking and stuff to make the box small again. So you can have, you know, this trick in some notebook that you don't distribute. You keep it for yourself to change the font size. And you do that to change the font size in your Jupyter lab and make things big, whereas everybody else is not doing this. You don't want to distribute this trick, for one thing, because it might not work. If Jupyter changes their class, their CSS class names, unlikely, but I guess they could. And also, if your students evaluate the cell and now whenever they run Jupyter, everything is big and they don't know how to change it back, that's a problem. So, so you probably don't want to distribute this trick if you use this trick. You might want to call it something like "Do not run IPy notebook" or something. But anyway, so there's that. Any more questions on this before I move on to the next topic with scrolling too fast? If not, I'll archive these questions. And let's go. I don't like leaving things unsaved. Okay. So, scrolling too fast. Let's, as an example, let's look at, I included a Ligo example notebook. And by the way, I love this notebook because when the first black hole signals were discovered in Ligo, they put it in a notebook and they put it out there. So like anyone can compute the same analysis. They can do the black hole analysis. You know, this is the ultimate of open source science. Nevertheless, it is a big, complicated notebook. And like, if I was going through this, let's say that I was presenting this, and for good measure, let me say I make the font size big. I say, oh yeah, so we discovered some black holes, and these are the things I'm going to tell you about. You know, so selected like this because I'm nervous. And intro processing, and okay, so you have to evaluate some cells. You do these inter stuff, and then you get, okay, this is the raw data. This is what the raw data look like when it's coming from Hanford and from Louisiana, HML, and the spectrogram, and we do some processing on it, and this is like the Monte Carlo simulation. This is what a simulated black hole would look like, and you do a bit more processing to clean up the data, and you got to whiten it somewhat. And look at this. This is the real black hole signal with the simulated on top, and you can see that there's really a black hole there. Isn't that awesome? And then the same for Louisiana. And see, you know about black holes. You know, that would be terrible. And part of it is the third point that I'll get to, which is too much code in the cells. This is the entire analysis, which is, you know, it's kind of amazing. You can get the entire analysis into a notebook. And, you know, and it's great for reading about this offline. You know, I could spend a few hours going through this notebook and learn about how to discover black holes. But there's no way I could give a talk on this. This is for the content in the size of the content in the cells, and how fast I'm probably going to have to scroll to get through it all. There's no way to follow that as a talk. So actually, the scrolling problem, this actually was the #1 comment at last PyHEP, when we had a lot of notebook talks and a lot of people doing it for the first time. The #1 complaint about the notebooks was that people were just scrolling too fast. And this reminded me actually that I started playing video games again this year. My daughter's getting me into it, and they're 3D now. So it's mind-boggling that you have to control the character with one hand and control a camera with the other hand. And so when I'm doing this, everybody gets seasick because the camera's going wild. But it's okay for me because there's the hand-eye coordination thing. If my hand is controlling this camera going everywhere, I don't get seasick, at least not the same way as people just watching it. And I asked her for a video that illustrates this.
You don't look happy. She doesn't look happy at all. And let's see what we can do. Oh my God, this is so sensitive. Look at this. I'm literally only moving my mouse a tiny little bit. What can we do here? Look at this.
That's what happens. It just, for people watching, just this blah is really a problem. So solutions, what can we do about that? And here again, I have to make this big. Okay. What can we do with that? One is just restraint. You got to learn, well, following this way, you just learn to keep your hand off the mouse. It's like self-discipline. You are thinking, you're thinking, oh, I'm going through this. I want to talk about solution 2A. I want to talk about solution 2B, and I want to keep moving the page. No, you shouldn't do that. You should just, allow the page to be not perfectly offset, and you just keep in mind that there is a human cost involved in every time you scroll. Or maybe don't even use the scrolly wheel, but always just use the scroll bar, which often has more control. Depends on how long the page is, actually. But if restraint isn't good enough, there's technology. There's other ways of doing this. The reason we get this complaint with Jupyter Notebook talks that we don't get with normal talks, like oops, where is it? This one, this PDF talk, is that in traditional talks, you see one page at a time. It's not scrolling at all. The way that you replace content is by going to an entirely different page. And the humans watching that without their hand on the mouse can follow that a whole lot better. So there are a few ways now of enabling a slideshow mode using Jupyter Notebooks. One, I'll say the best of these is Rise. Unfortunately, it's only available in Classic Notebook. And this here is the reason that I don't use it anymore. I used to use it all the time. Voila Reveal is very new. It uses Voila, a web server that serves dynamic content from your Jupyter Notebooks, from the IPyNB files. But it can only show pre-evaluated cell content. It can't reevaluate the cells, actually, for security reasons. So actually, I was talking with the developers about whether that might be relaxed if you are only sharing with localhost. You're only showing, you're showing slides. There's only one, there's no security issue because it's all running on your computer. And the third is more CSS hacking. I have a hack that will do this. So we'll see that third. So the first of these is Rise. Let me scroll nicely and make this size smaller. Oh, do you know if there's a way to make the page scroll down and align with the cell that I'm currently executing? Yeah, there is. This works relatively well. So first of all, you get into, you have to not be in the, you have to not be in the cell editing mode, but you get into this cell mode, you know, where you click on the left so that you're highlighting whole cells, and then then there are keystrokes that apply. K goes up one cell at a time, and J goes down one cell at a time. And that actually might be better than reaching for the mouse, because it will try to show the whole cell. It doesn't try to scroll it up to the top, which is something you might want, but it also does it in clicks. And that's kind of good, because if you're scrolling continuously, you might scroll too far and then have to scroll back. And that's the kind of thing that makes people woozy. So, so yeah, J and K is a good way to do it. And then you want to make your markdown cells the right size so that it's, you know, 1 unit of stuff to talk about. So anyway, to do Rise, we have to get into the classic notebook. And the reason that I don't like this solution is I don't know how long the classic notebook will continue to be supported. I asked about that on the Jupyter Gitter, and nobody's willing to say that classic notebook will be supported forever. So this will work as long as you have a classic notebook. And here I'm just going to use Rise's own README, which they have it set up so that, well, so it is a notebook, but they have it set up so that it will automatically go into presentation mode, which is a thing you can do with the metadata. If you don't do that with the metadata, then you have to install Rise, and that will give you this toolbar button. And this toolbar button goes into slideshow mode. Then there's some extra screen gunk here, all these little things. You can make, I type question mark, or help is H. Yeah, H. H brings up the keyboard shortcuts. One of these is, I think, comma makes the, I don't know if this is the keyboard shortcuts for slideshow mode. No. Oh, yeah, it is. One of these, comma, makes the, or control comma. I don't know what it is. Oh, it is comma, just it wasn't working before. Comma makes the screen junk go away. And so it's more like a presentation. Then you go forward and backward with space and shift space. So here, the Rise tutorial is talking about how you can slowly reveal things. And if you have input cells, you can shift enter to evaluate them. Here, I'm going to need to make this smaller. They automatically make the font size bigger. And creating slideshows with Rise, you have to think a lot about what will fit into one slide. Yeah, they're saying that if you're in a browser, you can do the font size thing that I already showed you previously. You can make plots. And then here's an example of where they made something that doesn't fit. So if you're presenting, you might need to double click on the output to make that hidden, and then maybe also make it smaller so you can get more onto the page. And you can see this thing. In fact, I still can't see it. There. And these are the problems with Rise presentations. of course, dynamic stuff works. All right, let's get back to normal size. And that's part of why I don't want to, it's relevant that the classic notebook might be going away because you write talks for Rise. You have to write them in a particular way. All right, you maybe installed the Rise extension, and now they're just talking about how to do it. Sub slides are down instead of to the right. I've never used that feature. You can have speaker notes. Oh, wait a minute. Now let me show you some of the things that they have a whiteboard. You can do this stuff, which I thought was super cool. This is new since the last time I used it. And what was the other thing? One of these was, oh, question mark gets you help. I really want to show the presentation mode because this was fantastic. Is it equals? No. I am not finding it. But there was a thing where you have a separate window showing you clear this out. There's something where you have a separate window showing you speaker. I think it's T. Yes. So look at this. Here you've got this little thing that you can put on your second desktop if you have one, where you can see what the next slide is going to be. And it's telling you how much time you spent, which, okay, I'm running low. And you can even control it from there. And you see that I'm moving the actual slideshow, so you can present this window and have this window off to the side. This stuff is great. Unfortunately, it's only in the classic notebook. So you can decide whether you want to take that, if you want to accept that. Something I was excited about as a possible alternative is Voila Reveal. So Voila is a server that serves the output of your IPy notebook files, and Reveal just connects that with reveal.js, which is exactly what Rise is using. So let's take the same Rise notebook and look at it in Reveal. So here I bring over a terminal, and we run that. Now this is another server. This is in addition to, or instead of, the Jupyter that we had. And we can use space. But the thing is, see this input cell? We can't click on it and reevaluate it. And that's for security reasons. Although I think if you're doing this as a spreadsheet, as a presentation, you're only running it on your own machine. You're not allowing anybody else to log into it. It should be, there ought to be like an unsafe mode where you can just allow you to evaluate cells. The one thing that you're able to do, if I could make this screen small enough, is this dynamic content. That's what Voila Reveal is really for. It's for these kind of widgets, and it's not intended for reevaluating cells. So the use case that I'd want to use it for, that's not what it's designed for. And in fact, so here I'm going to stop the Voila. Even showing the input cells at all was a non-default option. So strip sources is false is not the normal thing that you would do. So really the idea of this is not quite what the idea of Rise is. Okay, so that's two technological solutions. The third is CSS hacking. This is a lot like the font size thing that I showed before. Same thing, we're going to make an invisible HTML which has a style in it. And that style is going to change how notebooks are presented so that they're presented like a slideshow. And I used this for a while, but but there's a drawback, I'll explain. So here, I'll evaluate the cell, and it's going to do this CSS, which is a complicated little one-liner, but what it does is it makes all cells except for the current cell not exist. So they're not just invisible, they're in fact, they're not taking any space either. They go into display none. And now I really have to know the J and K keystrokes in order to go from one cell to the next, because that's now the only way to do it. So now I can, evaluate cells, and here you really don't want to do Shift Enter because that would take you to the next cell. So then you would be evaluating a cell and not looking at it, which is not useful. You have to train your hands to go between cells with J and K and only evaluate using Control Enter. And switch with the arrows as well. Yes, the up and down arrows, that do work. Oh yeah, cool. Thanks. The downside of this is only one cell at a time. So when I was using this more regularly, I was when I was using this more regularly, I had to write talks specifically for this. Anything that I want to have on a code cell can't be marked down. If I'm going to have an explanation, it has to be comments. And that's not great. So it's a cute trick, but it has limits. It has limitations. And there, I've reevaluated it so that the invisible HTML is not there anymore. There's no more output. There's no out8, and this is no longer hiding all but the selected cell. So when it comes down to it, restraint versus technology, really I've just been trying to use more restraint. Okay, so archive these, and any questions on this? The next topic is too much content in the cells. No questions, I'll just go on to that. Number 3, too much code in the cells. And the Ligo example is another good example of this. Here we are, the explanations are giant paragraphs. The code is giant code blocks. Not that this is bad, it's just not a talk. This is a report. This is something that you read. You spend a few hours reading this. It's not a thing that you present. But the problem is that I'll get back to that slide in a moment. Because Jupyter notebooks, or notebooks in general, are sort of a middle ground between programming, where you would have giant code blocks because that's what you're doing, you're programming, and terminal stuff where everything is these short, ephemeral, very readable things. Because it's covering that whole middle ground, I think people are encouraged to write giant code blocks in order to do something impressive, like an entire machine learning model, and present them as though they were these short snippets, which they are not. And it can be very easy sometimes to forget that, to not realize what it's like to be looking at this code block for the first time for less than 60 seconds. It's not just Jupyter. Of course, we all know that slides can be too complicated. This is a famous example because this was the slide that made the Department of Defense ban PowerPoint. And actually, some news sources from 2010 and even 2000, they didn't really like PowerPoint because this stuff happens. And when you've got a slide like this, you might as well just not even have a slide. This is not telling you anything. Yeah, but with Jupyter in particular, we've got to keep in mind that when we're showing code in a talk, this is not the same code that we write when we're programming. Yeah, so there's a temptation to expose full programs in your demo. Don't. Blinking HTML here. Don't do it. So, okay, maybe it's not enough to say what not to do. So let me show you an example of an attempt to get it right. And if it takes the last 10 minutes of this talk to do that, then I think that's time well spent. There was the one last issue of it doesn't work for me. There are cloud solutions, Binder, Swan, Jupyter Hub, and anyone who wants to stay late, we can talk about those. But for now, I'm going to try to demonstrate with a pattern rather than anti-pattern of what code blocks can look like in a in a talk. So here I'm going to use Rise. Here what I did was I made all these introductory cells skip, so they're not part of the presentation. And then the actual slides start here. So this is how you make a Rise presentation. You set the slide types. So I'll present it, and we start with, okay, let's say I'm giving a presentation on how to add. All right. So addition is wonderful. Everyone should learn to add, even you. So before we get to addition, we'll start with the basics. There are only 2 numbers. And notice what I'm doing here, the revealing thing. Very useful if you are doing something that's like this is the drama of it. This is a play. Those 2 numbers have some fundamental operations and or and XOR. So those are the basics. That's what you know about. The truth table for and or and XOR. And then as a quick reminder, Python can be used to calculate things. So let's define and or and XOR in Python. Here we have the inputs A and B, and I have the function definition and an example. This can be helpful for demonstrating a code example. And notice, like in Python, this is a dumb way to write XOR or and. We would use like an ampersand, or we would use, like for this one, I don't remember what the character is, caret, right? But how you write code when you're programming is different from how you write code when you're demonstrating. Here, what I'm doing is I'm making the function look like that truth table. That's the kind of, you're writing different kind of code when you're presenting something as a talk. Also, these F strings are great for code for talks because they're so concise. So something else you might want to do when you are when you just define some functions is to show them that it's working with some quick things and formatting them nicely so it's easy to read. This formatting involves some twiddling on my part, to get the right number of spaces here and such. But that extra stuff doesn't interfere with people's ability to read. Oh yeah, this is a for loop of A over 0 and 1, of B over 0 and 1. That's how you get these things. And then, yeah, it's evaluating this stuff because F strings are great for demonstrating that. It's easy to see that this is that. And then this truth table is the truth table we know and love. That's connecting it to something you already know. Before we can add multiple digit numbers, let's add single digit numbers. And the output for this has to be 2 digits because, as we know, 1 plus 1 is 2. There, 2. And so in the following table, showing the sum of all the possible sums of 1-digit numbers, note that the first digit is AND of A and B, and the second digit is XOR of A and B. So you say something like that about, you know, the concepts behind it before showing the code that just does that. So here is what I haven't explained why this is called half adder yet. You can float some things like that. The main thing that you'd be emphasizing here at this point is, look, in order to produce this truth table using what we've known, this is how you write the function. The function is one line. It's something that you can grasp, you know, live in a presentation. And then, because we made it, we test it. We show, oh, this is doing that thing. And so 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, 1 plus 1 is 2. Great. Incorporating graphics, such as this one that I got from Wikipedia, also great. I noticed a limitation of the classic, of using Rise inside the classic notebook part of Jupyter Lab that wasn't the case back when it was just the classic notebook, and that is that it wasn't able to find relative paths as in the markdown. And so I had to do that in a cell. It's stuff like that that's, you know, it makes me wary of this classic notebook. And then to add beyond a single digit, we need to incorporate a digit carried from the previous step. So continuing with Marble Machine's wonderful graphics showing how, you know, the circuit diagram of putting this 0 and 1 together with a XOR and another XOR, and then that's the first digit. And this is how you make the carry digit. And you got to bring in a carry digit. So really this is A plus B plus C in. And then this diagram, we can reproduce it with the code and showing the diagram and the code next to each other because we're trying to make the point that this is that. So I even made the code look like that at the expense of possibly making the code simpler. So here there's this point in the diagram where these two get XORed, and that's used in 2 different places. See, there's a dot pulling it into this, and it's pulling it into that. So this bit is reused, and so the code equivalent of that dot is defining a temporary variable and using it in 2 different places. So here, you know, if I'm showing diagrams in code, try to make the code look just like the diagrams, or try to make the diagrams look just like the code, because, you know, the audience is getting both of them. Your goal is not to make this an efficient function. It's to make it an understandable function. So another one of these truth tables where we're computing what we just made. This is showing that it works. 0 plus 0 plus 0 is 0, blah, 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 down to 1 plus 1 plus 1 is 3. And then we can talk about why this was called a full adder and the other was called a half adder. And that's because we're adding A, B, and C in, or A, B, and carry in. So we can add A and B and add the result of that with carry in, and that is a full adder. So this is equivalent to the simple full adder is equivalent to the full adder that I made to look like the diagram. And evaluating this, we can do stuff like show if the full adder result is the same as the simple adder result, we're going to put a check mark in the table. And remember, we can use all the Unicode. Just saying. and then make this this diagram. And because of a rise fluke, you know, if it doesn't fit, it's not, if evaluated code moves where this is and it doesn't quite fit, go to the previous slide and back again. And it sometimes readjusts it, and it did not readjust it this time. Okay. Sometimes you can make it fit by going to the previous slide and back again. Just a rise thing. Okay, so now that we have a half adder that will just add 2 digits and a full adder that will take a carry in and add that to 2 digits, now we can add 4, 8, 16, any number of digits we please. And it's just start with a half adder of the first 2, and then you sequentially carry it into the next, carry it into the next, carry it into the next. Sorry. This is just the following the addition rule that you do on paper, and so we can make counters that count up to 16 and such. So that's so you learn to add, and this of course was a meta presentation. This was to demonstrate what this kind of code what the kind of code should look like if you're going to be presenting it. So now I can ask questions about that, and also maybe you think that this wasn't such a good demonstration. Maybe I showed that and I thought you were all following along, and actually you weren't. It was still too fast, or too much code, or too little code, maybe too pedantic, or any of those things. So go ahead and tell me, or ask me questions, or anything. We're at the end of the hour, and for people who can stay and are interested in, oops, where are we? This 4th issue of it not working, and making consistent environments using Binder or Swan or Jupyter Hub. I'll talk about that later. But just letting people know if they've got other meetings to go to, that's the time is up. Questions, comments? Yeah. What are some good examples of a well-made Jupyter presentation? Well, I was hoping that the edition one I just showed, the little mini presentation, was such an example. Other examples, I don't have a list. If I see anything, yeah. I don't have a list offhand. That's actually why I did the edition ones, to try to demonstrate. If you start with conventional slides, what's the best way to transition to your Jupyter slides? Oh, and you're welcome. I feel like just a tab in a notebook is fine. Sorry, a tab in a notebook. Sorry, a tab in a browser is fine. So I've got a PDF viewer, but instead of using the PDF viewer, I used the web browser's PDF viewing, just because I can switch rather quickly, whether I'm sharing only one window or the whole desktop. If I'm sharing the whole desktop, then it's easy enough to switch between windows. But if I'm only sharing one window, it really helps to do tabs so you can do a quick switch. Any thoughts on a carpentry style talk where you're typing interactively and want learners to follow along? Yeah. Actually, I say a little bit about the levels of, let me make it big again. Levels of presentation interactivity, of which this one that I gave was basically level 2. And yeah, in carpentries, they go all the way down to level 5, which is good. I didn't feel like I had enough time to do that here, and also I don't know what the exercises would be. And also this presentation was a bit too meta. I wasn't sure how that would work. But yeah, how any thoughts on that? Well, the first thought is that Jupyter works really well for for all the levels of interactivity. Even if you're including formal exercises, you can do stuff like have the prerequisite code in a notebook, an explanation of the question in the same notebook, maybe in parentheses say that how much time they have, 15 minutes or whatever. And then in a different notebook that you hold aside so that people don't have the temptation to cheat, you have some solutions. You can definitely do that. But if you're going to do that, if you're going to go into interactivity 3 and above, it really has to work for them. And you will not have time to set up everybody's laptop, because if you've got 100 students, their laptops are configured in 95 different ways. So then you have to use some kind of a cloud service or something that flattens the playing field and gives everybody the same environment, so that when they evaluate stuff, it's just their own code that doesn't work until they get it working. I've used LaTeX for writing report. Jupyter's new to me. Can you elaborate how Jupyter's better than LaTeX? Well, I'm not actually going to say that it's better. You notice that I used both. I used this LaTeX slide. I should pronounce it right. I used this LaTeX slide for the intro stuff, and then Jupyter for the interactive stuff. Well, LaTeX is not interactive, so it doesn't have that. But in LaTeX, you can do much more elaborate things. When I used Rise a lot, and I tried to avoid the switching between the PDF slides and the Jupyter, and I wanted to just only present in Jupyter so that there's no switching, I found myself getting really elaborate with putting HTML in markdown cells in order to make the equivalent of what I could do much more easily with LaTeX, and certainly it's even easier with, say, PowerPoint, where you can just drag and click. So going to Jupyter slides, you lose the ability to make beautiful, elaborate, static slides, and you gain the ability to do interactivity. And that's why actually I think it's best to do both. I think that the beginning part, where people are just arriving, that's a good time for the static slides to give the overall context, and people come in from wherever their minds are, when they're walking into the talk, to thinking about what you want them to be thinking about. You use the static slides to prime their activation networks with the context, and then you can go into interactivity. So yeah, I use both. Is it possible to have slide notes that only the presenter sees? Yes, using Rise. Rise has a slide notes that the presenter sees, and you saw that I was still in the thing here. In this mode, this is where you can have your notes. I think the speaker notes go in this box here. And so then you just take this and you don't let people see it. You put it on your other desktop if you have one. And that's how you do presenter notes. Otherwise, you can write them on paper. And I would do that. I would write things on paper. Or like if we're talking about formal exercises, maybe I'll have those on paper. Okay, I think I've answered all of these questions. I will archive. And any more questions, any more comments? We're now 10 minutes over time. and I have the ability to keep going. I don't have a talk right now. So if anyone wants to hear about cloud solutions, you can stay. But keep in mind the meeting is over, the hour is up. If you want to hear about this and you can't be here because you have to go to another meeting, keep in mind we're going to put this on YouTube. And you can fast forward to this part. Okay. Everybody ready? Go into what if it doesn't work for me? This is relevant for especially the high levels of interactivity. As I said, like if everyone watches a pre-evaluated deck of slides, like I guess what Voila Reveal would do, or static slides, I'm not really sure why you're using Jupyter for that. Oops, darn. I did a bad thing and I double-clicked on a markdown cell. That's another thing to try to avoid. Double-clicking on a markdown cell makes it go into editing mode. Everyone watches you evaluate the cells. Okay, Jupyter is useful for that because you've demonstrated that this stuff runs in real time. You've made it clear that this is actual stuff that runs, but it's not really all that interactive. They're still just watching a show. You can ask everyone to press Shift-Enter along with you. And in these presentations, I have somewhere, I guess somewhere between 2 and 3, because I asked you to try this along with us. And this is a stronger demonstration that it runs because the audience is running it on the computers. Also, they're allowed to freely explore, although you're not really doing much to encourage that. The level where I'm usually at is this level 4, where I'm presenting and I stop every now and then and say, what if I evaluated this differently? And then, on the fly, change the contents of a cell and evaluate it again. And that not only shows that you can freely explore, but it's encouraging that kind of exploration and feedback. Like someone will try something and get something weird, and then they can ask it in the questions. But then, the full-on carpentry style talk, where you actually have formal exercises, that also works. And then it becomes paramount that they can run it on their own. So as I said, with enough people, they will have every possible configuration of stuff, including the stuff that you ask them to install. And if you say, please use pip to install this, maybe 3/4 of them will use pip to install it. And then some of them won't. The way to absolutely completely lose a tutorial session, particularly if it's in person and it's possible to go around helping people. Going around helping people getting stuff installed is where you'll just lose the whole presentation. There will be no time left. So you have to do something. You have to do something proactive. Everybody, Randall says that that his computer looks like this with 1 million Python installations. Yeah, the problem is even compounded if you're talking about not just one person's computer, but many. So solution 1, provide a requirements txt, which I believe is only used by pip, or an environment YAML, which I believe is only used by Conda. I might be wrong that they might cross-share with that, but primarily requirements txt and environment YAML, you get to specify exactly which packages need to exist. And if you run this right, if you set up a virtual environment in pip or a new environment in Conda, you can test it and be sure that, yes, I don't have extra dependencies on my computer that's making it work for me, that's not going to make it, that the students not having them won't work for them. You can do that and you can be very clean and safe if you can be sure that the participants in your presentation are going to correctly set up a virtual environment. And that is actually asking a lot if they're, coming from everywhere. Like if it's if you are presenting to a conference on Python packaging, maybe everybody has got, you can just say that and everybody will just do it flawlessly. But if it's about data analysis, then why are they necessarily going to have these skills? So you can fix that with cloud service. And that fixes things because you're not requiring the audience to install anything. Everybody has a web browser, so they can connect to a service that runs it for them. My favorite is Binder, because there's 0 credentials to log in. That's why also, actually, I like Slido, because 0 credentials, you take a phone picture of that and you're asking questions. But Binder is pretty limited. The CPU memory performance is limited. There's no GPUs. Any data that you want to include must be in the GitHub repo and can be public. If it's in the GitHub repo, that means it is small. Do not do it with more than a couple megabytes. And it's been fine for all of the kinds of presentations I've wanted to give, which have been about uproot and awkward array, which don't really need giant files. A small file will demonstrate the functionality. If you're giving a talk on machine learning and you need big data, then this is going to be a problem. Swan, if you're within CERN, this is great. The data can be hosted by CERN. You can use all the CERN things like CVMFS, CERNbox. Your audience will need to have CERN credentials. But then you can even use specialized compute and GPU. You can arrange that. CERN IPT can help you get that. Jupyter Hub is the oldest of these because it's not a service. It's a make your own service. It's the tools that you would use in order to host it yourself. And we've done that actually for some of our tutorials. Andrew Mello has hosted it for us using Vanderbilt computers. We've used SSL from IRIS-HEP to host some of these things. You have complete freedom, but you got to do it. Yeah, oh yeah, then I didn't provide any notes, but I was going to walk through binderizing this repo just so you can see how it's done. So now I have to do it ad lib because I didn't make notes. Here's how you do it. First, you get the URL for your repo without hash readme, if that's something. So you get the URL for your repo. Then you go to mybinder.org. Okay. Put the repo name here. And you can specify a branch tag or commit. And rather than doing this twice, showing you without and then with, I'm just going to do it with. This is a very good idea. It's a very good idea after you finish writing your talk to create a release so that you have a tag name v1.0. And the reason that this is a good idea is because the first time it sees a new version of a repo, it has to go through a long process of creating an image. And if you have a lot of dependencies in your requirements txt or your environment.yaml, it has to install all of those things and make this large virtual machine. And that takes time. Now, if you are just always using the head of your Git repo, then that's constantly changing. And so this launching process is frequently slow. The launch button, all that this launch button does is it goes to this URL. This is the URL, and it's actually a good idea to copy it now before launching, because once it launches, it goes into this other mode where it has a different URL and you don't have your URL anymore. It's kind of a UI problem. So I copy this and keep it because we're going to want to put it in our README for the GitHub in order to say how to get there. But here I'm just going to click it to show what happens. This is what someone will see the first time. It's building the virtual machine, because actually I didn't do this before. They get to see a little preview, but that's, it's, I guess the preview is good for seeing if you're looking at the wrong repo. We could have put a path to a particular notebook file there. So if you want to have just one notebook be the thing, rather than having to click into a particular IPyNB file, that's where you would put it. But as it is, now it has created the virtual machine. There's its name, it's launching. It has to launch every time. But yeah, we're just creating it. And now we wait. And wait. Okay, for Jupyter style talks on machine learning, thoughts using Binder, downloading the file with wget, or something Colab, Kaggle, something else. Actually, I don't know about Kaggle. That's another cloud source, cloud Jupyter notebook thing.
Yeah, it kind of is. So that was my question.
Okay, good. Okay, so there's another one.
Similar to Colab, I guess.
Mm-hmm. Colab I avoid because it's so non-standard. It's not exactly Jupyter, and has a different look and feel, and I don't know that they're ever going to get that fork remerged back in. But Colab has access to GPUs and TPUs, and I think with some Google credentials, you can put your data on Google Cloud. So now this, now that it finally launched, is running on Binder. It'll have only the Python packages I put in the Requirements Txt or the environment.yaml, which actually don't have one, so it has none. But here, it's also, notice in Classic Notebook, they still, Binder still goes by default to Classic Notebook. But yeah, here you are, and I wonder if this will work. Let's try it. Ah, interesting that this doesn't work. This trick doesn't work on Binder. A lot of weird little things like this. One thing I don't, in fact, I'm such a fan of using the same interface that I don't even like the fact that this is a Classic Notebook. Binder, Jupyter Lab, I have to look it up every time. How do you do it? It says you have to put question mark URL path lab tree, and then maybe a path to the file. It's sufficient to say, this is it, v1.0 is the tag. Let's see, URL path equals lab. Is there a slash? No, there's not a slash. That's it. That's not going to work. Okay, because I can see from the preview this can bring up Classic. Lab tree, didn't work. URL path equals lab tree. Page not found is not finding lab tree. Oh, but there's lab. How about that? Oh, maybe I was thinking the wrong thing. Maybe all you need is URL path equals lab, and that'll bring it up. And here I'm demonstrating in real time because, yes, I have to look it up every single time. I don't remember. So I guess it's question mark URL path equals lab. And other questions while this is loading? Downloading with wget, that certainly works. It'll have to download it to the Binder virtual machine, which might have limited disk space. And certainly that's a network transfer. So if we're talking about many gigabytes of data, then transferring it to this machine on Binder is going to be a limited rate.
So what would be your go-to for if you want a file that is bigger than you should include in a GitHub repo?
Yeah, well, so wget gets you a bit bigger than you should be in a GitHub repo, because GitHub repos really shouldn't be more than megabytes. If you want one file that's like 1 gigabyte, yeah, you can do that. You can do it with wget. Because 1 gigabyte isn't going to break anybody's download times or the virtual machine where this is running on Binder. By the way, Binder is being slower than usual here, but it happens, so something to be aware of. If we're talking about like 100 gigabytes or something like that, you just can't. I think you just can't use Binder. Not only would you not be able to get the data to it, but then you're not going to have the processing speed to be able to deal with it once it's there. So you're going to need special hardware anyway. Thing to know about Binder is that there are, I think, 4 or 5 servers total serving all the Binder in the world. And they do that by heavily oversubscribing it because most of the time these machines are idle. So right now it's idle. It's showing me this Jupyter lab that it's finally logged into, but I'm not computing anything. So so that time on the virtual machine is going to somebody else right now. And then as soon as I evaluate something, then this gets some CPU time and steals it from somebody else. So really the kinds of tutorials you can do here are showing functionality of a Python thing. If you really want to show a tutorial that uses significant resources, yeah, Colab, I guess Kaggle, setting up your own Jupyter hub, Swan, you have to. So, and then you're going to have to deal with permissions. So you get, I guess you get what you pay for. Free zero authentication, only good for small things. You need to do bigger things, then you have to set more stuff up. Anyway, other questions, because I'm out of material. This is everything. Oh, actually, I thought of something I was going to mention before about the Binder. It used to be that you couldn't save things. Now you can save notebooks, and maybe the wget files get saved too. Where is that saving going? On your computer. They're using the HTML5 local storage to put, essentially cookies into your web browser, where any modifications that you make to these files get saved in the the cookie that you have for this web page, this particular web page here. So in a sense, you get your own instance, but this is another reason not to download gigabytes, because then I don't think local storage, HTML5 local storage can even do gigabytes. So I don't know what's going to happen. Regarding your 5 levels of interactivity, any thoughts on how long a talk each one can accommodate? So how long you can, certainly if people are just sitting back and watching stuff, from like PowerPoint or Latex presentations that you really can't do this for much more than 45 minutes. Then with greater interactivity, that doesn't make the time that people are able to attend to it longer. But these kinds of things usually need like whole day sessions, like, you know, carpentries is a whole day thing. But then of course what you're doing is you'll have some presentations and some problem solving in a half-hour block, and then people take a break for 10-15 minutes, and then there's another half-hour block, you know, that sort of thing.
Okay. I should rephrase my question. Thanks for that answer. I kind of meant, I didn't word this well, but the minimum amount of time that is possible.
Oh,
so you obviously can't do level 5 if you've only got a 5-minute flash talk.
Absolutely.
Any thoughts on that?
Right. I was thinking about maximums, and you're talking about minimum. The reason I actually don't often go into level 5, where we have formal exercises, is that there's so much variance in how long it's been taking people to do them. So like I could make a problem that I think would take 5 minutes. And actually it takes some people 30 seconds and other people don't get it done after 10 minutes. Part of that is I haven't learned how to write good exercises. So that is very much an education thing and not a technology thing. But certainly 5 minutes is too little for like an entire talk. You're gonna have to provide context before you get into giving people a question, and the question has to be at least 5 minutes. So you're welcome. You know, I think that you can only start to have formal exercises if you are in some kind of a tutorial that's something like an hour to begin with. And then you might only have 1 or 2 formal exercises because each of them is going to take 10 minutes or 15 minutes on top of the problem of making it a hard enough / easy enough problem for everybody. All right.
Yeah, thank you. I've got a 30-minute slot in a something at university, and level 4 sounds quite enticing to me. So yeah, I think.
Okay. Yeah, I'll go for it.
30 minutes for level 4, maybe.
Yeah. And if you're really ad-libbing, you have to keep in mind that you will seem to yourself dumber during the presentation than you seem to yourself at other times. You know, when you're trying to edit some cell live, you'll mismatch the parentheses and all sorts of like things that you would consider rookie mistakes that I think that we do them all the time when we're not in front of a whole bunch of people, but we just don't notice it as much. You don't notice that, you know, it takes you 15 seconds to get the parentheses right until there's like 15 seconds of people like tapping their fingers, wondering when you're going to get the things right. So when you do ad lib, you know, it helps to try it ahead of time, maybe write down on paper the specific things you're going to try to ad lib. You might have a text file in the other window that people don't see where you can select and paste the different things you're going to try, because then, you know, you can be sure that the syntax will be right. Although that is a bit more canned. But yeah, I've found this level 4 to be at least optimal for me.
Thanks.
Jim, also, yeah, to add to that, I agree with it. For example, if you fancy using Rise, which has some benefits, such as, for example, to keep you focused on precisely just a few key points that you want to bring across, because you cannot fit enormous amounts of information, as you mentioned, on a slide. Then you still have the ability to maybe change one line to exemplify how you change an argument, how that in what that results, but you still have something very focused, and people they only have 2 or 3 lines maybe of code per slide, so it's probably something that you actually remember. If you want a bigger tutorial, then probably Rise is not too suitable. You would go, as you have done often now, through your notebook, but then you are interacting much more with the audience, requesting, can you actually run this? Would you like to change that? Give them a couple of minutes to try something out. So there, Rise doesn't work. I think those are really, as you said, actually very well. Those are 2 different presentations, type presentations.
Mm-hmm. Yeah. Yeah. Oh, in fact, in my my demonstration of a good talk, where I was showing small code snippets tightly connected to the narrative, I didn't do any interactivity. In fact, I didn't think of that. You know, probably I should have demonstrated some interactivity by trying things. You know, what happens if we add this number and that number? You know.
Yeah.
Yeah. Okay. If there are no final questions, we are more than half an hour over. The last thing, okay, that's more on the slide looking thing, like Rise versus scrolling. Scrolling emphasizes even more that it is code. I don't know that scrolling tells us that it is code. Evaluating it shows that it is code, and modifying things while evaluating. And actually, I've given Rise presentations where I've modified things on the fly, and that works just as well as if you're in scrolling mode. Actually, a problem with scrolling and evaluating cells is, and also if the cells are too large, is that if a cell is very large, evaluating it can cause it to scroll. And the code evaluation and scrolling at the same time is usually just cognitively too much. So, but that's really just an argument for smaller code cells. Okay. Actually, I think it's a good time to stop being.
Yeah, thank you very much, Jim. That was excellent.
Okay, thanks. Okay. And probably talk to you later, because we're all in the same Slacks and Gitters and things.
Thanks very much. And thanks for making it available to us from this.
Oh yeah, welcome.